good bet now? Okay.
It should work, yes.
Hello, everyone. My name is Mustafa. I'm part of TUM AI. And as you already heard, I've gave almost the same presentation 3 times already. This is the 3rd time. So as a member of TUM AI, I'm part of the education department. And our goal has been, and always will be probably, to make AI easier and accessible to people who may not have had the chance to learn AI in any point in their life, right? And me, personally, I see myself as an educationer. So I like to always share information about stuff that I find pretty useful. As a career, I'm a data scientist. I'm a researcher in AI. And I've been part of 2 work in progress startups. One of them is going strong. And I do some AI and consulting for people who are still starting up but don't have an AI engineer. But we don't have to talk about me so much. We can jump straight in. So I already heard that yesterday was a bit tough. The series today is a bit technical. We're going to learn how to use tools to not only create stuff ourselves, but to also utilize stuff that have already been created by other people. And we're going to talk about why this should be important. So the first thing is API. And apparently there was no intro slide. But API basics. Has anyone heard of APIs before? OK, great. Has anyone used them in a way? Great. So we're going to start by taking a step back and talk about a world without any APIs, which is the monolithic world. I've went ahead and asked GPT what a monolithic world is. And it says monolithic applications are self-contained software systems where all components and functionalities are integrated in a single code base. This is where you put everything that you have in a single application. This application does not require internet, does not require any external data of any sort. You can think of this as a mobile game that is offline, for example. You can play, you can do everything. Everything is stored on your machine, and it's fine. And this is great because if the internet goes out, if you don't have enough energy from outside, your phone still probably works, and the app doesn't break. However, when you put the UI, the logic, and the data, and the logic here is all your code, all the information that you need your app to calculate, when you put all of that in one place, you might run into issues. Let's consider GPT for an instance. GPT is a huge model. It has a lot of parameters, which means that it's too huge, too large. And when you put that on a mobile device or even like your laptop, it might not have enough space or enough resources to keep that model there, let alone all the data that I need to give it to GPT, take all the data out, and so on and so forth. Another problem might be that, well, models like GPT are also very computationally expensive, which means they take too much to calculate and they're too complex. And when we think about that and we put everything on one application, your application is going to be laggy, it's going to be frustrating, and no one's going to want to use it. So the best thing to think about it, well, if the logic and the data are a problem, how about we just pull them out? And then we keep just simple logic that does only the bare minimum on my application, and everything else is away. Now, if at some point I come to things that, well, I need more space, I need another place to put my data, or I need another complex logic, what can I do then? Well, we can just create as many of them as I want. And then the only question is, well, how do we connect all of it, right? And this is where APIs come in. So does anyone know what API stands for? No. Application Programming Interface. Yes. So application programming interface, again, I asked GPT, but it's a set of rules. It's an interface that explains how you can connect to information on the internet. Basically, every time you go to Google and you search something, there is in itself an API call. And we're going to see that mostly everyone here has interacted with as many API calls as there is. So again, we're going a step back to look at the monolithic application. And this is, let's say, how you interact with GPT if everything was on your own machine. You send a message to GPT, you wait for it to respond, the response comes back to you. It's pretty simple. It just might be a bit laggy because GPT might take some time to respond, but it works. But what we're going to do is we're going to decouple it, where we're going to put the client at some point and the agent at some other point, and then we need the API in the middle. And then we need, like I said, a way to communicate between them. So the way it works, very simply, you send the message to the API forwards this message to your GPT, your agent, and then the API waits for you until at some point when the GPT or the agent at some replies and be like, hey, here is the answer, and then the API sends it back to you. So the overall picture looks something like this. And to simplify it even more, we can look at it as a very simple example. Pretty sure everyone here has been to a restaurant at least once. A monolithic side of a restaurant where you cook at home. You have to go into the kitchen, you have to look at what you have, you start cooking it, and while you're cooking it, you cannot really leave, otherwise you might break something, burn something. and then when you finish, you eat, you clean, and you leave. But in a restaurant, the waiter in that point is the API. And the waiter comes back to you, shows you a menu. This menu is your documentation. This is everything that you need to ask for stuff to come out of the kitchen and onto you. And then you choose something that you like, you ask the waiter for it, the waiter goes back to the kitchen and asks for it, right? And then in that time where you're waiting, you can do whatever you want. You can ask for the waiter to come back, you can cancel your order, you can just walk away and leave, you can do whatever you want, right? And when the waiter gets whatever response from the kitchen, it's going to come and carry it back to you. And this response could be, whatever you ordered does not exist today, this is finished, we don't have it anymore, it doesn't work, or here is your food, it's great, it works. And converting that to code, we're going to see that, well, the client is you, it's whatever you see on your machine, whether it's something you created yourself, or it's the web page that we're looking at, the GPT web page. And then when you send the request, the server, this is your client server, what you see in the front, sends it all the way to the back where all the complex logic is handled and sends it back to you. Everything good until this point. Okay. Right. So how are the applications structured, right? Well, we have, like I said, what is called the front end. This is what users see on the front. And we have a back end. This is all the complex logic. And it's very nice because the UI is very beautiful. It's what everyone sees. And then the back end is just a jumbled mess of code. And just everything goes wrong. And the nice thing about it is if something breaks in the back end, you always have to make sure that whoever is looking at the front end does not realize that something went wrong, right? And what we see here is like the UX is pretty, this is what you see when you go into a web page, the GPT web page again, and then the back end is all the code, all the processing, and everything that happens behind your back. So we talked about the API taking information and telling you about the response. We want to talk a bit more about how this response is structured. How do you look at the result that you're getting from the API and actually understand if my request has been completed or is it broken, right? And this is where response codes come into play. Every request that you ask for, every request that you submit, gets responded to with a response code. And these response codes are one of three. It's the best one we like, a successful, everything went great, your request has been completed correctly. And then there are two types of errors. There are errors that the client made, the client did something wrong, and then there's errors that the server did something wrong. So let's go one by one. The successful request, in standard, everyone, as well as we will in a bit, will only check for 200. 200 is the standard for the request was completed successfully. There is only 200 and 200, 1, 2, 3, and 4. However, they're not very used in practice, and ideally, you have all the bands from 200 to 299. This is that signifies that everything is correct. And then client errors is something that the client did wrong, and it broke on the client side. This is something like 404 not found. You search for something that does not exist. The server did not crash, the server did not break, but it told you that you did something wrong. And then server-side errors are whenever you do something that breaks the backend. This could be because the developers did something wrong, that just broke everywhere, or your input was not compatible, but the developers did not add an exception for it. They did not handle such an input, for example. So as a rule of thumb, if it breaks on the back end, it's 500. If it breaks on your side, it's 400. In most cases, what we will do and what you will see when you're writing code, you only check for the success. Because anything else, it doesn't matter. It only matters that your result was not completed. In more advanced settings, you might want to know exactly what happens and then check the stack trace. But we don't have to worry about that for now. So what are the use cases for using APIs, right? Like we're talking about it for so long, but why would I use it? And the idea is that you integrate with internal and external services, which means you can create a service that is now hosted as an API. We'll talk about that in deployment. Or you're using an external service that's been created by someone else, aka the GPT API, right? And this is nice for you because you reduce your cost, because instead of hiring a lot of people that implement this for you, you already find a API that does exactly what you want, and you don't have to create it anymore. And this adds and enhances your functionality because you can scale so easily. Everything that you need probably has an API that you can just log on to use and just, you have it. And now you just have a widely scalable application of so many tools that you can use. And you can use APIs and like WebSockets in general to connect between different devices that you have in case you have hardware devices, IoT devices, and Internet of Things. And last but not least, it improves the organizational security And this is because everyone who's building a service at some point might need to add authentication. Now, authentication is something you can do by hand, but it's way easier for you to use a tool that has a lot of security built into it. For example, if you're working with payments. Now, you can do payments, but you can already use a tool like Stripe, for example, that has all of the payment security interaction with banks that you don't have to implement yourself. So, what kind of APIs do you guys use? I want to hear from you. Any random API would be nice. OpenAI. It's one of the ones I have. What else? Google Docs. Yeah, Google Docs use a lot of APIs in the backend. What else? There's something more useful. Probably everyone checks it almost once every day. The weather app. Someone say weather app? Yeah, nice. Google as well. Yeah, if you search on Google, that's also an API. So I have a set of ones that I prepared for you today. The weather app. Almost everyone, whenever they go wake up, they check how is the weather today. It's sunny, you go out and it's raining. We all been through it, right? And the way it works is, well, there's a bunch of places that have a lot of sensors, and they read all of this data. They come up with how the weather is looking right now, and they use machine learning and AI to predict a few steps in the future. Now, this is a bit simple, because whenever you're calling the weather API, it does not calculate specifically for you. It just reads the most up-to-date data. So it's nice, it works, everyone sees what the weather is like, and this is why it's always a bit wrong sometimes, but it can be a bit more complex. We can look at the Google Maps API. Google Maps API calculates based on you in real time whenever you want to go. It takes where you are, where you want to go, does all the AI to figure out the best path, and then there's the traffic, and this is all calculated in real time, and if you did it on your phone, it will probably lag because you'll just be waiting there for so long while it calculates every possibility that it's just going to be so frustrating to use Google Maps, right? And the final one, everyone's favorite website, right? GPT. You have the UI in front of you. You write your prompt. It just takes that prompt, sends it back. The GPT does its system prompt that OpenAI has already implemented, a bunch with a lot of other prompts that they have and a lot of other systems, and then it just sends you the text in a streaming way. And this just to show you that there are multiple different APIs of different types, and some of them are more complex than others, and you never really feel that it's taking so long or that it's lagging on your end unless your internet is bad, you know? So again, we can talk about why would you use an API, but it's just a clear copy of what we just said in the use cases, right? It's efficient. You use a lot of data that's already been implemented by someone else that you don't have to do it yourself. It gives you access to more information, and so on and so forth. However, nothing comes without any limitations. So with all the good that APIs give, that they also comes with a lot of cons, and some of them are contradicting. So for example, you do have security concerns. It does give you security and governance when you're using some tools, but it does come with security concerns, because if you're sending all of your data and all of your client data over an API to a third-party asset, you have no idea what they're going to do with it, right? Now, in Europe, you have GDPR. In the US, not necessarily. And then you have the dependency on third-party assets, right? Let's say your entire service uses GPT as a system, as a service. And OpenAI decides we will no longer be doing GPT as an API. Your entire system will fail, because you're so dependent on that API that if it changes or is removed, your entire system can break. As well as complexity. When you're trying to add many APIs at the same time, you might end up with an API that needs a specific structure in your code base and another API that needs a different structure, and trying to make it compatible is just a trade-off between how much effort do I want to put to change my code base to work with a different one, or how much effort it is to create that one myself. This is always what you have to consider when you're building these things. And of course, there's costs and licensing. We did say that it's cheaper to use an API, but it depends, right? Because if your API is based on the users, if you have so many users and they're all making so many requests, you're just going to be paying so much money rather than the amount of money that you're paying to implement it in-house, and then not pay per every inference, let's say. And then, of course, it's limited customization. If you're using an API created by someone else, they did not create it specifically for you. They created it in a general way, which means if you wanted to do something that it doesn't do, it's just going to be tough to get it to do exactly what you want it to do. There are some modular and like open source great things that you can enhance, but in most cases, APIs exist. There's like, this is the documentation, this is what we have, and nothing else. So always keep that in mind. And with that, we're going to be writing our own API codes ourselves. Actually, we're not going to be writing our API codes ourselves yet because we're going to step on deployment. But is there any questions about API? Does anyone understand the notion of having an API that we call and get information from? Great. Right. So moving on, there's a Slido feedback.
I think we can skip that one and go for the next one.
Great. Moving on from APIs, we want to talk about deployment. Now, deployment is a way for us to put code, our services, our systems on the cloud. This is basically what we talked about. We want to decouple our systems and put it on the cloud. This is the step that we talk about that. And that means that you are now the API. You are now the person who people will use as a service. And it's great, right? Whenever you write a code, we're going to see that it works on what is called your local host. This is basically working only on your local network, which means no one around you outside of your Wi-Fi can contact it. And deploying it means you put it on a certain IP address that everyone can connect to. So let's break it down, or not. Let's break it down. And the way it works is that whenever you have code that you're ready to deploy, you need to code review it and you need to optimize it. Code reviewing is very important. Has anyone heard about what happened with CodeStrike? No? Microsoft, all the Windows breaking, all the Windows machine breaking? Yeah, this is code reviews, right? 1 extra 0 broke every Windows machine in existence. So it's very important to check your code, make sure that it has no errors, and that it's actually ready to deploy. And then you have to configure some environment configurations. This is basically your API keys. If you're using external services, you need to make sure that these are not available to everyone else, because at the end of the day, you don't want some hacker to just walk in, find all your keys, takes it for themselves. And you want to think about where do I host my system? Where do I put it up there? And then you need to do testing, quality assurance, and finally, continuous integrations. And ML DevOps is a way to maintain your systems. If you have like a machine learning model, for example, and you put it on the cloud for people to use, every now and then, let's say every week, every month, you need to get that model, test it to see if it's still relevant, and then deploy it again. And it's different for different systems. But it's key steps that you always have to think about. Right. So how do we deploy, right? Well, you have to start considering your API. Is it a public use? Does everyone get a chance to use it? Is it for everyone? Is it for private use? Is it only for your company? Is it only for you? Is it something for private funds that only pay for it? And is it based on tokens? When people register, do they get like 1,000 tokens and then they work? Or do they have to pay per token like GPT and so on and so forth? These are all stuff that you have to decide based on the effort it took to build the API and deploy it, plus how many people are using it and how much it costs to use it every time. And then you have to, again, consider, well, where do I deploy? There is Google Cloud, there is Microsoft Azure, there is Amazon, and so many more opportunities. So here's, I guess, some of you's first chance to look at code. This is a Hello World API deployment code. Basically, the entire file is 6 lines of code. The other ones do not matter, but we want to focus on this for a bit. You see the @app.route? This is a syntax way of saying this is what people will be searching for. So when you say google.com/, this is the route, this is the endpoint that I'm looking at. And then we would see that the / is what goes on to the local host, and this is where you do the Googling, right? Now, what is 127.0.0.1? Well, this is what we, again, says is the local host. This is what you have in your home network. Now, this is what we call an IP address. And IP addresses are basically for every website. So google.com has an IP address that you just don't see. You write google.com, you hit enter, and then there's something called a DNS server. S stands for server, right? Yeah. It's like DNS server, whatever. And then this DNS takes your IP, it takes your search, right, your google.com, and change it to whatever IP address, and it goes there. So for now, if you're working at home, it's 127.0.0.1. Otherwise, we will talk about it in a bit. But what you do here is that you define a function, and this is what explains when people go to that route, this is what I want to happen. And here we're just returning hello world. It's pretty simple. It's like we're printing hello world, basically. And now we want to do something a bit more complex. I want to be able to have my website or my API take input and interact based on that input. And we talked about this. Yeah. and then we just add a parameter. Basically, the brackets, the parentheses, takes a parameter name, and this is the same one you can use in your function. And then I can just parse it into my string. Now you'll see that I have the string with an f. This just allows us to put a variable inside that string. And then you can see that on the other side, it takes the names that I just entered, Venture Labs. It will be in the endpoint, and it will be able to print it because it takes it as a parameter, which is great. It's already sometime more complex, but we can do a bit more, right? How about we call an API from within our API? Why not, right? You can do anything you want within your function itself. Now, this code we will see in just a bit. We will actually write it. And what it does is that it calls an API that is a placeholder. It's made to teach people how to call APIs, basically. And it returns what we call a JSON object. It's basically a dictionary that has a value and a key and a bunch of those, right? So the key, for example, would be body, and then the value would be all the nonsense text that comes afterwards. So it's already a bit complex, but it works. Do we have any questions? Are we scared already?
Does everybody understand the syntax as we have it right now?
You don't have to focus on this function, but we can focus on this one. It's easier. Yeah. But like, does this make sense? The idea of it. Let's not worry about the code too much, because we'll worry about it in a second.
Yeah.
Right, so whenever I run something, it's 127.0.0.1. If you run it, it's 127.0.0.1. However, we will see something that is called colon 500. Now, this is a port. This port is user-defined. And the way it works is that, consider in the restaurant idea, you have multiple servers, and every server listens to a set of people, right? So for example, if I want to build 2 front-end services and 2 back-end services, and I'm at home, they're all going to be on 127.0.0.1, but I can decide which port they want to listen to. This is basically a tunnel that takes all of your information only to the listener of that tunnel, right? But 127.0.1 is not existence, it's not something, it's just your local address. It's an empty web page. So if you don't add something onto it and you try to Google it now, it'll be empty. However, you can think of this the same way. If you get a router and you want to go configure it, it has a local host, right? And you go to that and you log in, and then you can configure the router. This is the same idea. Any other questions? Do we feel prepared to write code? OK. So now that we have the endpoints, we created them, we want to talk about deployment. Well, this is where we actually take it from the 127.0.0.1 and put it somewhere on the cloud. There are 2 ideas that I added here, is like Pingy and Ngrok. This is basically a way to create a tunnel, just like the port, that takes the information from the IPS server that we just created, and it follows it through to your local machine, takes the input and sends it back. This basically creates an API for your API. However, these are for test deployments. These are a way for you to demo your work, to show people. I'll show you that in a second. And it allows people to interact with your APIs. But then when you want to actually put it out there, you're going to need to go to something a bit more reliable, a bit more scalable, and gives you a bit more customization, right? Now, this is, again, Azure, AWS, or Google Cloud, or other services. Yeah.
Yeah, that would be a great time to quickly